Welcome on this tutorial. Wish all you are well. In this tutorial, I am going to explain different numerical problems on maximum power transfer theorem. I shall solve problems and explain step by step. After different numerical calculations and solving the problem, I shall check it by using Proteus simulation. Please go through full tutorial. It will be very much helpful for you. Subscribe my channel. It will encourage me to upload more and more important tutorials. Problem number 1. Find the value of R in the circuit such that maximum power transfer takes place for the rest of the network. What is the amount of this power? So this is the complicated circuit. Here R is the load. We have to calculate what will the value of this load resistance so that maximum power from the source will be transferred to the load resistance. According to maximum power transfer theorem, maximum power will be transferred from source to load resistance if load resistance is equal to source resistance. That is, RL is equal to RS. RL is the load resistance and RS is source resistance. Now what is the source resistance? Except load resistance, whatever will be the resistance from rest of the circuit, this will be considered as source resistance. So to find out the source resistance, we need to find out a single source and a single resistance which will be equivalent to this circuit. That single source might be voltage source or current source. Here say, throughout my discussion, I am using voltage source. So we need to find out the equivalent voltage source and resistance of this complicated circuit. And here we will use the Thevenin theorem. So throughout this tutorial, whichever the problems I shall solve here, I will use Thevenin theorem to find out equivalent source and equivalent resistance. This is my original circuit. I need to find out Thevenin voltage and Thevenin resistance except the load resistance. To calculate Thevenin voltage, the load resistance should be removed. So the load resistance has been removed. Now voltage across these 2 points X and Y, that is the Thevenin voltage, and this is also termed as open circuit voltage. So now I need to find out this VOC. I shall explain the full procedure. Yet if you face any problem to understand, please pause the video and try to make it clear. Now here, what is this VOC? This VOC is voltage across X and Y. In between this X and Y, there is a resistance 1 ohm and a voltage source. If we consider this is positive and this is negative, here this is plus minus plus minus. VOC will be the summation of voltage across this 1 ohm plus this 6 volt. Say this is that part. Now to find out this voltage across 1 ohm, that is VAB, that will be current through this 1 ohm multiplied by this 1. So I need to find out current through this 1 ohm. How to find current through this 1 ohm? Current will be produced because of this source. So this I is the main current. At this point, it is having 2 paths. This is one path, this is another path. In this path it is I2 and in this path this is I1. That I2 is flowing through this 1 ohm resistance. So somehow while I shall be able to find the value of this I2, that I2 multiplied by 1 will be the voltage across this 1 ohm. Now to find out this I2, what we need? First we need what is the main current I. How we will calculate it? To calculate this I need the source voltage and the equivalent resistance of whole circuit. Because I is equal to the source voltage V divided by R. What is this R? R is the equivalent of combination of this resistance. So V is equal to 4 volt. What is R? To find out R, we will look towards this. So what is happening here? This 1 ohm which is in series with the parallel combination of 2 paths. This is one path, this is another path. So first this 2 and 5 plus 1, that is 6. 2 and 6, that is in parallel path, and that will be added with this 1 ohm. Say this 6 is in parallel with 2 and equivalent of this is in series with 1 ohm. So this is value of R. So this B by R, that is current, ultimately we will get 8 by 5, this main current I which is flowing from source. So I got this I. Now to find out I2, what is I2? I2 is equal to opposite path's resistance divided by total resistance multiplied by main current. So say I2 is equal to opposite path resistance, that is 2, divided by summation of resistance of both paths, that is 2 plus 5 plus 1, multiplied by main current I, that is 8 by 5. So ultimately we got 2 by 5 ampere. What is this? This is value of I2, this current. So I need to find out VAB. So what is VAB? VAB is equal to current through this 1 ohm multiplied by this 1. So VAB is equal to 2 by 5 multiplied by 1, that is 2 by 5. This is VAB. So what is VOC? Open circuit voltage, that is VAB plus 6 volt. So ultimately we got 6.4 volt. So 6.4 volt is VTH. Now we need to find out RTH. To find RTH, what we shall do? We will remove this R. Say I have removed, and all the sources will be replaced by their internal resistances. This is the voltage source. No internal resistance has been mentioned here. So this will be considered as ideal voltage source. For ideal voltage source, internal resistance is 0. So this will be shorted. Here this is shorted. Similarly this will be shorted. Rest things are as it is. So this is the circuit to find out RTH. What is happening here? If we move towards this, we will get two paths. This is one path, this is another path. So these two are parallel. Again, this path here divided into two paths. This is one path, this is another path. So these two are in parallel. So these two are in parallel. Equivalent of that will be in series with 5, and equivalent of those is in parallel with 1. If we cannot understand this, we may redraw this circuit in a simple way. Say I am starting walking from X. So this is X. This has been divided into two paths. One path is this 1 ohm. Another path is 5 ohm. This 5 ohm again divided into two paths. One path is 1 ohm and another path is 2 ohm. And this is connected at a particular point, this one. This point and this point at same point. So this is ending at a particular point which is Y. So from this it is clear 1 and 2 first in parallel. See 1 and 2 parallel. Equivalent of these two is in series with 5. Equivalent of this is in parallel with this 1 ohm. Ultimately we got 0.85. So this 0.85 is RTH. Now putting VTH and RTH in equivalent circuit. This is Thevenin equivalent circuit. VTH is 6.4 volt. RTH is 0.85 ohm. Value of this load resistance should be equal to value of this RTH 0.85 ohm to get the maximum power at load. Now putting value of open circuit voltage and load resistance to get maximum power at load. Ultimately I got 12 watt. So this is maximum power at load. Now checking whichever calculation I have done here, whether it is correct or not. See here, this is equivalent circuit with Thevenin voltage 6.4 volt which I have calculated. Thevenin resistance 0.85 ohm which I got after calculation, and this load resistance I have used with the same value as to get maximum power at load. In main circuit also I have used same value of resistance as load 0.85. Now if I get power at load in main circuit and power at load in equivalent circuit are same with the value 12 watt, then it will be confirmed that whichever calculation I have done, all are perfect. Now running the simulation. See in main circuit it is showing power at load is 12 watt. In equivalent circuit also it is showing power at load is 12 watt. So all my calculations are correct. Problem 2. I need to find out value of this load resistance to get maximum power from rest of the circuit, and also I need to calculate value of maximum power at load. I shall follow maximum power transfer theorem. To make the video short, I shall try to explain it quickly. If you face difficulties at any point, please pause the video and try to make it clear. So first, to find out open circuit voltage, remove this resistance. I have removed it. Now potential between these 2 points X and Y is open circuit voltage, and that is VTH. Now the open circuit voltage is the difference between voltage at X and voltage at Y. Now what is voltage at X? Here at this point this is 10 volt and no current is flowing through this path. So potential at this point and potential at this point are same. So Vx is equal to 10 volt. Now what is the potential Vy? Now Vy with respect to this point, because this is the ground. So what will be Vy? It will be current multiplied by this 5 ohm. So this Vy, that is actually VAB, which is drop across 5 ohm. So how to calculate that drop across 5 ohm? That will be this 5 multiplied by this current. Now what is this current? This current will flow due to this source through this path. So this I will be 24 divided by 10 plus 5. So ultimately I got potential at this point is equal to 8 volt. So that is Vy. So Vy is 8 volt. So ultimately Voc is 2 volt. This is VTH. Now to calculate RTH, I should remove this and all the sources will be replaced by their internal resistances. This is the current source, that will be open circuit, and this voltage source, that will be short circuit. So ultimately we got this. To get the value of this RTH, here 10 and 5 are in parallel. Equivalent of this is in series with 2. If you cannot understand it, redraw it in a simple way. Start from here. This is starting from here. It is having two paths. One path is 10, another path is 5. This is 10, this is 5. This is meeting at a particular point. From that point another resistance is 2. And ultimately the other point, say this is A, here this is A, this is B, this is B. So it is clear 10 and 5 are in parallel and 2 is in series with equivalent of these 2. So ultimately RTH I got 5.33 ohm. So this is the equivalent Thevenin circuit. To get maximum power at load, the value of load will be equal to RTH. So see, the load resistance is 5.33 and this is Thevenin voltage. Using the formula, Pmax is equal to open circuit voltage divided by 4 into RL. So ultimately putting the value, I got 188 milliwatt. This is maximum power at load. Now showing the simulation to make it clear whether my calculation is perfect or not. This VTH, this is RTH, load resistance should be equal to RTH. So this is the equivalent circuit, and in main circuit I have used the same value of RTH as load. What is my calculated maximum power? Calculated maximum power is 188 milliwatt. Now see whether I am getting that 188 milliwatt in main circuit and the equivalent circuit. Running the simulation. See here in main circuit it is showing 187 milliwatt, almost equal to 188, and in equivalent circuit I am getting 188 milliwatt. So my calculation is perfect. Problem 3, I need to find out value of this load resistance to get the maximum power from rest of the circuit, and also I need to calculate the maximum power at this load. I am following maximum power transfer theorem. First I need to find VTH. For that I am removing this load and I am going to calculate this open circuit voltage. Here what is this open circuit voltage? Voltage across X and Y. As no current is flowing through this 5 ohm, so potential at X is equal to potential at A. So actually VOC is potential at A with respect to point B, which is equal to this 10 ohm multiplied by current through this 10 ohm resistance. So this one. Here a negative sign is here. Why this negative sign? Because I am using the nomenclature as BAB. So potential at this point with respect to this point, as current is flowing down to up through this 10 ohm resistance. So here this is positive, this will be negative. So BAB is just negative of this magnitude. So 10 multiplied by I. Now I need to find out the value of this I. This I will flow only because of this source. So what will be I? I will be this 50 divided by the full resistance, that is 1 plus 3 plus 10 plus 1, that is 50 divided by 15. So 10 multiplied by 50 divided by 15, ultimately I got minus 33.33 voltage, which is BOC, that is BTH. Next I am calculating RTH. So removing this load and replacing the source with its internal resistance, as this is voltage source that is shorted. So this part is equivalent resistive network. Here up to this 3 plus 1 plus 1, that is 5, is in parallel with this 10, and equivalent of this is in series with 5. So ultimately I got RTH is equal to 8.33 ohm. So this is the equivalent Thevenin circuit. BTH is equal to minus 33.33 volt, RTH is equal to 8.33. To get the maximum power at load, the load value will be equal to RTH, that is the source resistance. So see, RL is equal to 8.33. Using the formula, the maximum power value is equal to 33.34 watt. Now using the simulation to say whether my calculation is right or not. Say this is BTH, this is RTH, which is equal to the load resistance is similar as RTH, and in the main circuit also I have used the same load resistance 8.33 ohm. Now if I get same power in main circuit and in equivalent circuit, and if it is 33.3, then it can be confirmed that my calculation is perfect. Now running the simulation. Say in main circuit power is 33.3 watt, in equivalent circuit also power is 33.3 watt, and also it is same with my calculated power. Problem 4. I need to find out the value of this load resistance to get maximum power at load. Also I need to calculate value of maximum power at load. I am following maximum power transfer theorem. First I need to find out BTH or open circuit voltage. This is the main circuit. To simplify the main circuit, at left side of this AB, that is this portion, I am using Thevenin to use it with single voltage source and a resistance. So while I will use the Thevenin of this portion only, there is a current source, this is one resistance, and if I use the Thevenin, what will be Thevenin voltage? This Thevenin voltage is potential across this resistance, so that will be current multiplied by this. What is the value of the current? Current is 2 ampere, so that 2 ampere multiplied by 10, that will be 20 voltage. So BTH is 20 voltage. See here. What is the RTH? For RTH, I shall open this current source. So here RTH is just 10 ohm. See, this is 10 ohm. So this is simplified circuit. To find out BTH, I need to open this one. So I have opened this one. Now the open circuit voltage here is actual BTH. What I did, I just converted this circuit into a voltage source and resistance. The rest part are same. So what is the open circuit voltage here? This open circuit voltage is voltage across this 2 ohm resistance plus this 10 volt. If I consider this is positive, this is negative, then positive, negative, positive, negative. So this VOC will be voltage across this plus 10 volt. So this one. Now what is voltage across this resistance? Voltage across this resistance is this current I multiplied by this 2 ohm. Now what is this I? I is equal to total voltage in this circuit divided by total resistance. Now see here, minus plus plus minus. If I consider this voltage as positive, this will be negative. So ultimate, the equivalent voltage of this loop is 20 minus 6. So 20 minus 6 is the voltage, and resistance is 10 plus 5 plus 2, that is the circuit resistance. So this portion is the current, that multiplied by this 2 ohm, ultimately I got 28 by 17, that is potential drop across this 2 ohm resistance. So that will be added with this 10 to get this VOC. So ultimately this VOC is 10 plus 28 by 17, I got 11.65 volt. This is VOC or Thevenin voltage. Now to find out Thevenin resistance, I need to open this load resistance. Here I have opened, and current source will be open. This current source is open. This voltage source is shorted. Voltage source is shorted. So ultimately I got this. From here it is clear that 10 plus 5, that is 15, is in parallel with 2. 15 in parallel with 2. Ultimate I got 1.76 ohm is RTH. So this is the equivalent Thevenin circuit. RTH is 1.76, VTH is 11.65. To get the maximum power at load, according to Maximum Power Transfer Theorem, load resistance should be equal to Thevenin resistance, that is 1.76. And using the formula to get maximum power, I got maximum power at load is 19.2 watt. Now checking it in simulation, whether I am getting the same value 19.2 watt or not. Say this is RTH value, load resistance is same with RTH. This is open circuit voltage, and in main circuit I have used load resistance same as 1.76 ohm. Now checking whether power at main circuit and equivalent circuit are same with value 19.2 watt. Running simulation. See, in main circuit it is showing power at load is 19.2 watt. In equivalent circuit also it is showing power is 19.2 watt. So my calculation is perfectly okay. Problem 5. I need to find out value of this load resistance to get the maximum power from rest of the circuit. Also I need to calculate the maximum power at load. I am following Maximum Power Transfer Theorem. First I need to find VTH or open circuit voltage. So removing load resistance and the voltage across this X and Y, that is the open circuit voltage, which is VTH. I need to calculate this one. I need to calculate potential between point X and Y. So this is VOC. To calculate this, I have to find out potential at this point and potential at this point. Now what is potential at this point? Potential at this point is equal to current through this resistance multiplied by this resistance. Now considering potential at this point is Vx. Now this point are same point. So the main current, this one, has been divided into two parts. One part is this one, another part is this one. So this 5 ampere current will be summation of this current and this current. What is this current? This point potential is Vx. So Vx divided by 5, this path current I1, and Vx divided by 2, this path current I2. So see, this is I1, this is I2, and summation of these two is 5. From this I got Vx is equal to 7.143 voltage. This is potential at this point. Now potential at this point Vy. Now this Vy is equal to VAB. Now here the current is flowing through this path. Now when this is the direction of the current, here it will be positive, it will be negative. So Vy will be minus of 4 multiplied by this current. So minus of 4 and this current, value of the current is 2. So Vy is equal to minus 8 volt. Now VOC is equal to Vx minus Vy. VOC is equal to Vx minus Vy. Value of Vx is 7.134 minus value of Vy is minus 8. Ultimately VOC is 15.134 voltage. Now to find RTH, the load is removed. See here, this current source will be open this current source is opened. This is the circuit to calculate RTH. Here this 5 and 2 are in parallel with 4 in series. This 1 is not in the circuit. If it is difficult to understand for you, then you can redraw the circuit in a simple way. Say this is point A and this is point B. Start from point A, having two paths. One path is 5, another path is 2. Meeting at a particular point. From this point another resistance is 4. So this is 4, this is 5, this is 2, and ultimate this is the point B. So it is clear that 5 and 2 is in parallel and 4 is in series with that. Ultimately I got 5.43 ohm RTH. So 15.14 is Thevenin voltage, 5.43 is source resistance. To get maximum power at load, the value of load should be same as RTH, that is 5.43, and using the formula I got 10.6 watt is the maximum power at load. Now checking whether I am correct or not. See here, this is Thevenin voltage, this is Thevenin resistance. The load resistance should be equal to Thevenin resistance, that is 5.43, and in main circuit also I have used 5.43. Now if I get power same as 10.6 watt in main circuit at load as well as in equivalent circuit at load, then it can be confirmed that my calculation is perfect. So running the simulation, say the power here it is 10.6 watt, in main circuit also 10.6 watt. So my calculation is perfectly okay. Problem 6. I need to find out value of load resistance to get the maximum power from rest of the circuit, and also I need to calculate maximum power at load. I am following maximum power transfer theorem. I need to find out VTH, that is the open circuit voltage. So removing this load, and the potential across this is the open circuit voltage, that is VTH. The rest part is same. To find VOC, ultimately I shall use this loop tree. The summation of this source, potential drop across this 5 and this VOC will be equal to 0. Now to get voltage across this 5 ohm, I need to find current through this 5 ohm resistance. To calculate current through this 5 ohm resistance, I am using this loop and this loop. Say current through this loop in this direction is I1, current through this loop in this direction is I2. Now from first loop, I1 current is flowing through this 20 ohm resistance. So this is positive, this is negative. In 2 ohm resistance, I1 is in this direction and I2 is in this direction. So I1 minus I2 is flowing in downward direction. So polarity is this is positive, this is negative. So I1 into 20, this one, and 2 into I1 minus I2, this 2. Now summation of these three in this loop is 0. Now see, this is minus plus, this is plus minus plus minus. These two are in series and this is in series opposition. So if we consider this 20 as positive, this will be negative, this will be negative. So 20 minus this one is equal to 1. From here I got 11 I1 minus I2 is equal to 10. This is equation number 1. Now from loop 2, I2 current is flowing from left to right. So here this is positive, this is negative. I2 current is flowing through this 5 ohm resistance. So this is positive, this is negative. Through 2 ohm resistance, I2 is in upward direction and I1 is in downward direction. So I2 minus I1 is flowing in down to up. So this is positive, this is negative. So see, this is plus minus plus minus plus minus. So summation of these three will be equal to 0. So this is 10 into I2, 5 into I2 plus 2 into I2 minus I1 is equal to 0. So ultimately I1 is equal to 8.5 into I2. This is equation 2. Solving this equation 1 and equation 2, I got I2 is equal to 0.108 amperes, which is flowing through this 5 ohm resistance. So what will be voltage across this 5 ohm resistance? This is 5 multiplied by I2, ultimately 0.54 volt. This is this voltage, and polarity is positive and negative. Now using KVL in this loop, this is plus minus minus plus minus plus 0.54. So ultimately using KVL here, this VOC minus this 50 minus this one is equal to 0. So ultimately I got VOC is 50.54 voltage. Next, calculating RTH, removing this load. Now looking through these points X and Y, we see that the equivalent resistance I shall get from this resistive network, that is RTH. If it is difficult to understand which one is parallel, which one is in series, then redraw this with a simple one. So I am starting from this X. So say this is X point. Here I got two paths. One is 5 ohm, another one is 10 ohm. So I got one path which is 5, another path which is 10. Here I got again two paths, one is 20, another one is 2, 20, another one is 2. These two resistance meets at a particular point, this one, which again meets another side of 5 ohm. So, and this point is ultimately Y. Now it is very easy to understand that first 20 and 2 are in parallel. It will be in series with 10, and equivalent of this is in parallel with 5. Ultimately, after calculation, I got the value of RTH is 3.5 ohm. So this is equivalent Thevenin circuit. Thevenin voltage is 50.54. Thevenin resistance is 3.5. Now to get the maximum power at load, the load resistance should be equal to this, that is 3.5 ohm. Now putting the value of open circuit voltage, that is VTH, in this equation to get maximum power, I got the maximum power is 182.44 watt. Now checking whether my calculation is perfect or not. This is equivalent circuit. Thevenin resistance 3.5, load resistance should be equal 3.5, and in main circuit I have used load resistance as 3.5. Now if I get power at main circuit and power at equivalent circuit are same, and if it is 182.4 watt, then it can be assured that my calculation is perfect. Now running the simulation. Say in main circuit is 182 watt, in equivalent circuit also it is showing 182 watt. Sort of the calculation I did, that is perfectly okay. Problem 7, I need to calculate the value of load resistance to get maximum power at load. I also need to find out that maximum power at load. I am following maximum power transfer theorem. First, I need to find out open circuit voltage. So removing this load resistance, here this, keeping the rest part as it is. This is our target potential, which is VOC. To calculate this, I am considering the node voltage at here is V. Now see here, this is 2 ampere current. Here this point and this point are same point. So using KCL at this point, 2 ampere is inlet current, which is summation of this current, say I1, this point at this point same point, this current say I2, and this current say I3. So using KCL at this node, this 2 ampere is equal to I1 plus I2 plus I3. So what is I1? Here the potential, at this point potential is V, and at this point the potential is potential drop across this 1 ohm. So I have mentioned here as V 1 ohm. What is I1? I1 is the potential difference across this 10 ohm resistance, which is V minus V 1 ohm. So I1 is equal to V minus V1 divided by 10. This one, B minus B 1 ohm divided by 10. Next, I2. What is I2? I2 is the current flowing through this path. Mainly the difference between these 2 points is B minus B 1 ohm. Again, here is certain potential, that is 20 volt. So ultimately the potential for this I2 is B minus V1 ohm minus this 20 volt. So that potential divided by this 2 ohm is equal to I2. Say this one. Next, I3. I3 is flowing in this direction. At this point the potential is VOC. So I3 is V minus VOC divided by 5 ohm. So this I1 plus I2 plus I3 is equal to 2 ohm. Simplifying this equation, I got this relation. Now here, what is V1 ohm? V1 ohm is equal to current multiplied by this 1 ohm. What is current through this 1 ohm? See, this current is flowing in this path, and here a current source is 5 ampere. So the 5 ampere is flowing through this 1 ohm. So V1 ohm is equal to 5 ampere multiplied by this 1, that is 5 into 1, that is 5 volt. So V1 is equal to 5 volt. Now putting this 5 volt in this equation, I got this one. See here, V1 ohm is equal to 5 volt. Ultimately I got the relation 0.8 V minus 0.2 VOC is equal to 15. This is equation number 1. Now using this node, here in this direction on current is coming out from this node. This is inlet current, another current is in this direction. So using this node, this current will be equal to sum of this current plus this current. So this is I1, this is I2. Now value of I1 is for 2 ampere, but what is I2? I2 is equal to this VOC, this point at same point, VOC minus V divided by 5. So VOC minus V divided by 5, this is I2, and I1 is equal to 2, which is equal to inlet current 5. Using this relation, I got this equation, which is equation number 2. Two variables V and VOC, here also V and VOC. By solving these two equations, I got VOC is equal to 45 volt. If you face any problem to make it clear, just pause the video and try to understand. Now to find RTH, open this load resistance. Say this is open, current source is open, here C open, this current source is open, C open, this voltage source is short. So ultimately this is the combination of resistances to get this RTH. Now if you feel any difficulty to understand which one is in series or in parallel, redraw the circuit in simpler way. Say at point, this is point A, this is point B, start working from A. So this is A, is having single path 5, this is 5 ohm. Next two paths, this is one path, this is another path, 10 and 2. One is 10 ohm, another one is 2 ohm. This meets at a particular point. From here 1 ohm, and ultimately I got B. Now from here it is easy to understand that 10 and 2 are in parallel. Say first equivalent of this in series with 1 and 5, and ultimately I got 7.6 ohm, which is RTH. Now this is equivalent Thevenin circuit. BTH is equal to 50.54, RTH is equal to 7.67. To get maximum power at load, load resistance should be equal to RTH, that is 7.67, and using this equation to get maximum power, I got maximum power is 66 watt. Now checking whether my calculation is perfect or not. This BTH, RTH, load resistance is equal, and here in main circuit I have used load resistance is same as 7.67 ohm. If I get power in the main circuit and equivalent circuit equals with 66 watt, then it can be certain that my calculation is perfect. So running the simulation, say Here it is showing 66 watt. In main circuit also showing 66 watt. So out of the calculation I did to solve this problem, it is perfectly okay. Problem 8. We need to find out the value of load resistance RL to get maximum power from the source, and also I need to find maximum power at load. I am following maximum power transfer theorem. I need to remove this load resistance to get open circuit voltage. So this is the same circuit, R has been removed. So this is VOC, open circuit voltage. The rest parts are same. What is VOC? VOC is potential at this point A with respect to B, that is BA minus BB. So VOC is equal to BA minus BB. Now what is BA? As this is ground, BA is potential at this point A, that is voltage drop across this 30 ohm resistance. How to find voltage drop across this 30 ohm resistance? It is the multiplication of this 30 ohm and the current flowing through this 30 ohm. So what is the current? This current is produced due to this source. So this current will be equal to this source 180 divided by the full path resistance, that is 180 divided by 10 plus 30. So this is the current flowing through the 30 ohm resistance, that multiplied by 30 ohm, this is potential across this 30 ohm resistance, which is BA. So this is BA. Now what is BB? Similarly, BB is the potential across this 40 ohm resistance, that will be multiplication of 40 with current flowing through the 40 ohm resistance. So again from this loop, what is the current? Current is, because of this 180 voltage, so 180 divided by full path resistance, that is 20 plus 40. So this is the current flowing through 40 ohm resistance, that multiplied by 40 is the voltage across 40 ohm, which is VB. So this is VB. So VA minus VB, ultimately it is 15 volt. So open circuit voltage, that is VTH, which is 15 volt. Now trying to find out the RTH. For RTH, removing this load, say I have removed it, source voltage will be replaced by their internal resistance. Here the voltage source, no resistance has been mentioned here, so it will be considered as ideal voltage source. Internal resistance is 0, so it will be shorted. So this is short. So this is ultimately the resistance combination to get RTH. If it is difficult to understand which resistance is in series or parallel, you may redraw this resistive combination into a simpler one. Say I am starting from A, so this is point A. It is having two paths, 10 ohm and 30 ohm. So redrawing it with two paths, 10 ohm and 30 ohm. This is 10, this is 30. It meets at a particular point. This point and this point are same point. This point are same point. So from this point, I am again getting two paths. One path is this 20 ohm, another path is this 40 ohm. So from here, I am getting two paths. One is 20, another one is 40. So this is 20 ohm, this is 40 ohm. These two again meet at a particular point, and from that point it is B. So this is equivalent of this resistive network in a simpler way. Now it is very easy to understand that 10 and 30 are parallel, 20 and 40 are parallel, and equivalent of this one and equivalent of this one are in series. So ultimately from this I got 20.8 ohm, this is RTH. So putting RTH and VTH in equivalent circuit, this is that equivalent circuit. RL is load. To get maximum power at load, the value of this load resistance should be equal to this source resistance, which is RTH. So see, load resistance here it is 20.8 ohm. Now using this formula Pmax, open circuit voltage square divided by 4R, ultimately I got maximum power at load is 2.7 watt. Now checking whether my calculation is perfect or not. See, this is equivalent circuit, 15 volt VTH, 20.8 ohm RTH, and load resistance is same value, 20.8 ohm. In main circuit I have used load resistance as 20.8 ohm. Now if I get power at load 20.8 in main circuit and power at load 20.8 in equivalent circuit are same, and which is equals to this 2.7 watt, then it will be confirmed that whatever the calculation I have done, that is perfect. Now running the simulation. See here, in main circuit it is showing 2.7 watt. In equivalent circuit also it is showing 2.7 watt, that is maximum power at load. So my calculation is perfect. Problem 9. I need to find out value of load resistance which is connected across A and B. So here is that resistance RL, and also I need to calculate the maximum power at load. Here I will use the maximum power transfer theorem. So this is the same circuit to calculate open circuit voltage. Before calculating it, I simplified the circuit a little bit, considering this and these 2 points, and left side of this point I applied Thevenin's theorem. When I apply Thevenin's theorem, then VTH will be voltage across this 20 ohm resistance. In that case, this 2 ohm is flowing through this 20 ohm. So 2 multiplied by 20, that will be 40 voltage, that is the VTH, this one. Or will be RTH at this circuit, this current source will be open, so 20 ohm resistance is RTH. So this is RTH. So this portion of the circuit has been converted into a voltage source and a single resistance by using Thevenin. The rest part of the circuit are same. So ultimately I got this circuit which is equivalent of this left hand circuit. Now to find out this VOC, this is open circuit voltage. The open circuit voltage, this VOC is potential at point A with respect to this point. So this is equivalent of this voltage source and voltage drop combination. If the current through this 20 ohm is flowing in this direction, then potential drop will be, this will be positive and this will be negative. So what will be VOC? VOC is this potential drop minus of this one, because these have been opposite polarity. This is plus minus, this is minus plus. So potential drop across this minus of 10 volt is open circuit voltage. So this one. So to get the potential drop across this 20 ohm resistance, what I need to calculate current through this 20 ohm. This current will flow because of this 10 volt and 40 volt. These two sources are there in this loop, and the resistance is just 20 and 20. So current will be the combination of these two voltages. This is plus 40 volt, this is minus 10 volt. So total voltage is 40 minus 10. This 40 minus 10 volt divided by full path resistance, that is 20 plus 20. This is the current flowing through this 20 ohm resistance. So that will be multiplied by this 20 ohm is ultimately potential drop across this 20 ohm resistance. Through this calculation, ultimately I got VOC is 15 volt. Now to calculate RTH, this is the main circuit, this is the position for RL. This voltage source, that will be shorted, and the current source, this will be open. So ultimately this is resistance combination to get RTH. It is very clear that here 20 ohm and 20 ohm are in parallel. If we start walking in this direction, we get two paths. One is 20 ohm, another is 20 ohm. Ultimately these two paths meet at a particular point here. So this 20 and 20 are in parallel. After this parallel calculation, I got RTH is 10 ohm. So using equivalent circuit, this part is Thevenin equivalent. RTH is 10 ohm, VTH is 15 volt. To get maximum power at load, value of load resistance will be equal to this RTH. So it is 10 ohm. By using this maximum power formula, I got it is 5.62 watt. Now checking whether my calculation is okay or not. This is equivalent circuit with VTH 15 volt, RTH 10, and load resistance is same with that 10 ohm. Same load resistance has been used here in the main circuit. Now the power at load in main circuit and power at load in equivalent circuit, if these two are same and value of it equals to 5.62 watt, then it will be confirmed that my calculation is perfect. So running the simulation, say in equivalent circuit is showing power at load is 5.62 watt, and in main circuit power at load is 5.62 watt. So whatever the calculation I have done here, everything is correct. Problem 10. I need to find out value of this load resistance to get maximum power at load, and also I need to calculate the value of maximum power at load. I am following maximum power transfer theorem. This is main circuit. So first I need to find out open circuit voltage. So load resistance is removed. See here, load resistance has been removed. Rest part of the circuit is same. So I need to find out this VOC, open circuit voltage. This VOC is potential at this point with respect to this point. No current is flowing through this 2 ohm resistance, so potential at this point is equal to potential at this point. So VOC is potential at this point with respect to this point. What is that? It is just a potential drop across this 6 ohm resistance. So to find out potential across this 6 ohm resistance, I need to know the value of current flowing through this 6 ohm resistance. That current multiplied by this 6 ohm is the potential drop across this 6 ohm resistance. Now what is this current? This current will flow because of only this source, that is 12 volt, and the current will flow through this path. So value of resistance will be full path resistance, that is 12 plus 6 ohm. So ultimately this 12 volt divided by 12 plus 6 ohm, this is the current flowing through this 6 ohm resistance. That current multiplied by this 6 ohm is ultimately VOC, and we got 4 volt, which is the value of open circuit voltage. Now we need to calculate RTH. So open this load resistance here, and sources will be replaced by their internal resistances. So this will be shorted here. So this is circuit for calculating RTH. It is very easy that this 12 and 6 are in parallel, and equivalent of this are in series with 2. So 12 and 6 are in parallel, equivalent of this will be added with this 2. Ultimately RTH I got 6 ohm. So this is the equivalent Thevenin circuit. VTH is 4 volt, RTH is 6 ohm. Load resistance will be same as RTH to get the maximum power at load. Value of RL is 6 ohm. By putting the value in the formula to get maximum power, I got maximum power is 0.67 watt. Now checking whether my calculation is perfect or not. This is the equivalent circuit. 4 volt is the Thevenin voltage, 6 ohm Thevenin resistance, and load resistance is equal to same as Thevenin resistance, which is 6 ohm, and in main circuit the load resistance I have used at 6 ohm. Now power at load in main circuit and power at load in equivalent circuit, if these two are same, then we can ascertain that my calculation is perfect, and power at this wattmeter should be 0.67 watt. Now running the simulation, say in equivalent circuit power at load is showing 0.67 watt. In main circuit also power at load it is showing 0.67 watt. So my calculation is perfect. Problem 11. I need to find out value of this load resistance to get maximum power at load, as well as I need to calculate value of maximum power. I am following maximum power transfer theorem. First I need to find out the open circuit voltage. So load has been removed, and voltage here is the open circuit voltage. See here, this point and this point, potential across this point is the open circuit voltage. The rest part are same. Now simplify this circuit, getting 2 points. This is A and this is B. Converting the left side of this AB into a single voltage source and a single resistance by using Thevenin theorem. So if we convert this into a single Thevenin voltage and single Thevenin resistance, it will be 20 volt and 10 ohm. Say if we open the circuit from here, the circuit looks like this. This is the current source, which is 2 ampere, and this is 10 ohm. So what is VTH? The current flowing through this 10 ohm resistance. So here current is 2 ampere. That 2 ampere will flow through this 10 ohm resistance. So 10 multiplied by 2, that is 20 volt, that is VTH. Say here 20 volt is VTH. Now to calculate RTH, this current source will be open. So ultimately 10 ohm is RTH. So this is RTH here. So this circuit, this part of the circuit has been converted to this part of the circuit by using Thevenin. Keeping this part same, this below circuit is equivalent of above circuit. So now to calculate VOC. What is VOC? VOC is potential at this point with respect to this point. So in between these 2 points, what are there? That will be the summation of potential drop across this 2 ohm resistance and this 10 volt. To get potential drop across this 2 ohm resistance, I need to find the current flow through this 2 ohm resistance. So what is the current flow through this 2 ohm resistance? The current will flow in this loop. So 2 sources are here, 20 volt and 6 volt. See here, this is minus plus, this is plus minus. So if we consider 20 is positive, this will be negative. So equivalent voltage is 20 minus 6. So this is the circuit voltage, and the circuit resistance is 10 plus 5 plus 2. 10 plus 5 plus 2. So this is the current flowing through 2 ohm resistance. That current multiplied by 2 is potential drop across this 2 ohm resistance. So this is potential drop across 2 ohm resistance, and polarity is this is plus, this is minus. So this is plus minus plus minus. So equivalent of this combination will be VOC, and that will be addition of this potential drop plus 10. So by using that, ultimately I got VOC is 11.64 voltage. So this 11.64 voltage is open circuit voltage. Now I need to find out RTH. So load resistance should be removed, and this is current source. So this current source will be removed and it is open circuit. This voltage source will be short circuited. So here this is short. So after that I got this combination of resistances to find RTH. It is very clear that here 10 plus 5, this is in series, so 10 plus 5, that is 15, is in parallel with this 2 ohm. So by using that, ultimately I got 1.76 ohm. This is RTH. So putting the value in equivalent circuit, VT is 11.64, RT is 1.76 ohm. To get maximum power at load, the value of load resistance should be equal to 1.76 ohm. So I have used RL as 1.76 ohm. By putting value in the formula to get maximum power, ultimately I got 19.2 watt is maximum power at load. Now checking whether my answer is perfect or not. See here in equivalent circuit, Thevenin voltage is 11.64 voltage, Thevenin resistance is 1.76 ohm. Load resistance I have used with the same value 1.76 ohm. In main circuit also load resistance is 1.76 ohm. Now if the power at load in main circuit and power at load in equivalent circuit, if these two are same and the value is 19.2 watt, then it can be confirmed that my calculation is perfect. Running simulation. See, in equivalent circuit power at load is 19.2 watt, in main circuit power at load is 19.2 watt. So my calculation is perfect. Problem number 12. I need to find out the value of load resistance to get maximum power at load from rest of the circuit, and also I need to calculate value of maximum power at load. I am following maximum power transfer theorem. First I need to find the open circuit voltage. So removed this load here. Potential across this and these points is the open circuit voltage. To get the value of open circuit voltage, I am using nodal analysis. Say at this node potential is V. This point and this point are same. So using KCL at this node, this is inlet current 5 ampere. This current has been divided into 3 paths. One is this one. Say this is I1. Another one is this one. Say this is I2. Another one is this one. Say this is I3. So this 5 ampere is the summation of I1, I2 and I3. So first, what is I1? I1 is the current flowing through this 1 ohm resistance. So potential at this point is V. So V minus this 15 volt divided by 1 ohm, this is I1. So see, this is I1. Next, what is I2? I2 is B, this is ground, so B by 10 ohm, this is I2. So this is I2. What is I3? I3 is flowing through this path. So I3 is this B divided by 2 plus 3, this is I3. So this I1 plus I2 plus I3 is equal to 5 ohm. Simplifying this, I got value of V is equal to 15.4 volt. This is potential at this point. Now what is VOC? VOC is potential at this point with respect to this point. Now this is open circuit, so no current is flowing through this path. So potential at this point is same as potential at this point. So VOC is potential at this point with respect to this point. So VOC is equals to current flowing through this 3 ohm resistance multiplied by this 3 ohm. So what is current through this 3 ohm? So current through this 3 ohm is value of this V divided by 2 plus 3. So value of V is 15.4 divided by 2 plus 3. This is the current flowing through this 3 ohm, that multiplied by this 3 is the potential across this 3 ohm. So ultimately VOC I got 9.24 voltage. Now to calculate RTH, open this load resistance. Here the sources are replaced by their internal resistance. The current source will be completely open. Say current source completely opened. Voltage source will be shorted. Voltage source is shorted. So this is the combination, and from this resistive combination I need to calculate RTH. If it is difficult to understand which resistance is in series or which resistance is parallel, then we can redraw this combination of resistances in a simpler way. Say I have started from this point A. Say this is B. So from A I am starting walking A, first 5 ohm resistance. From this 5 ohm resistance I got two paths. This is one path, this is another path. So one path is having 2 ohm, another path is having 3 ohm. This 2 ohm, at this point again we got two paths, one is 1 ohm, another one is 10 ohm. So from this 2 ohm, two paths, one is 1 ohm, another one is 10 ohm. This 1 and 10 met at a particular point. Say this is that point. This point and end of 3 ohm are same. So this 3 and these are same point, and ultimately the point is B. Now it is very clear that which one is in series, which one is in parallel. So first 1 and 10 are in parallel. Say this will be in series with 2 ohm, this one, and combination of this is in parallel with 3. So this is parallel with 3, and combination of whole is in series with 5. So this is plus 5. So ultimately say here 10 parallel 1, equivalent of this is in series with 2, equivalent of full is in parallel with 3, equivalent of this full is in series with 5. So ultimate after calculation I got 6.47 ohm. This is RTH. Putting it into equivalent circuit, VTH is 9.24 volt, RTH is 6.47 ohm, and to get maximum power at load, the value of load resistance will be equal to this 6.47 ohm. See here 6.47 ohm. Putting the value of open circuit voltage 9.24 and the resistance is load resistance, that is 6.47 ohm. Ultimately we got maximum power is 3.29 watt. Now checking whether my calculation is okay or not. See here in equivalent circuit I have used 9.24 volt, 6.47 ohm is Thevenin resistance. The load resistance is same as 6.47. In main circuit also I have used load resistance 6.47 ohm. Now if power at load in main circuit and power at load in equivalent circuit are same with the value 3.29 watt, then it will be confirmed that my calculation is perfect. Now running the simulation. See here, in main circuit is showing power at load is 3.29 watt. In equivalent circuit, power is showing 3.30 watt, which is very near to 3.29 watt. So my calculation is perfect. Problem 13. I have to calculate value of load resistance to get the maximum power from rest of the circuit, as well as I need to calculate value of maximum power at load. I am following maximum power transfer theorem. First, I need to open the load and I need to calculate open circuit voltage across these 2 points. So keeping rest part of the circuit as it is, this is the circuit to calculate open circuit voltage. Here, say the point, this is A, this is B. So VOC is BA minus BB. So this one. Now what is BA? BA is potential at this point with respect to this point. That is current flowing through this 2 ohm resistance multiplied by this 2 ohm. So what is the current flowing through this 2 ohm resistance? This is 5 ampere. So that 5 multiplied by 2, that is 10 volt, is value of BA. So say BA is 10 volt. What is BB? Similarly, BB is potential at this point with respect to this point. So BB is current flowing through this 5 ohm resistance. So what is current through this 5 ohm resistance? Current will flow because of this 24 volt and that will flow through this direction. So what is current? This 24 volt divided by full path resistance, that is 10 plus 5. So 24 volt divided by 10 plus 5, this current flowing through this 5 ohm resistance. So that current multiplied by this 5 ohm, ultimately I got BB. So value of BB is 8 volt and value of BA is 10 volt. So ultimately open circuit voltage VOC is equal to 2 volt. Now to calculate RTH, remove this load. Load has been removed and sources will be replaced by their internal resistances. So current source is open and voltage source is shorted. So ultimately this is resistive combination to get RTH. Here it is very easy to understand that this 10 and 5 are in parallel. Equivalent of these two is in series with this 2 ohm. So using that 10 and 5 parallel with series 2, I got 5.3 ohm is the value of RTH. Now putting value in Thevenin equivalent circuit, VTH is 2 volt, RTH is 5.3 ohm. Load resistance should be equal to this RTH 5.3 ohm to get maximum power at load. Putting value of R and open circuit voltage in this formula, maximum power I got 188 milliwatt. Now checking whether my calculation is perfect or not. Say VTH 2 volt, RTH 5.3 ohm, load resistance same as RTH, that is 5.3 ohm in equivalent circuit, and in main circuit also I have used the load resistance as 5.3 ohm. Now if power at load in main circuit and power at load in equivalent circuit are same with the value 188 milliwatt, then it will be confirmed that my calculation whichever I have done, those are correct. Running the simulation. Say in equivalent circuit it is showing 189 milliwatt, very similar to 188 milliwatt, and here in main circuit it is showing 187 milliwatt. It is also almost equal to 188 milliwatt. So my calculation is perfect. Problem 14. Determine the value of R. This is that R, so that the load of 20 ohm should draw maximum power. This is the load. So I need to find value of this R so that maximum power will be transferred to this 20 ohm load resistance. Next part. the value of maximum power drawn by the load. I need to calculate the maximum power at load. According to maximum power transfer theorem, maximum power will be transferred to load when load resistance will be equal to source resistance. Now what is source resistance? Source resistance is equivalent resistance of this part of the circuit. So I need to calculate Thevenin voltage of this part of the circuit as well as Thevenin resistance of this part of the circuit. And Thevenin resistance of this part of the circuit will be equal to 20 ohm according to maximum power transfer theorem. So first here I am calculating value of this resistance. So my target is to find out RTH. To find RTH, I need to open load resistance. Say I have opened this part and the source will be replaced by its internal resistance. So this will be short circuit. So now what is RTH? RTH is the parallel combination of this R and 60 ohm. So I am using R parallel 60 ohm. This is the value. Now this RTH should be equal to load resistance to get maximum power. So this is equal to basically 20 ohm. Say this is equal to 20 ohm. Using this relation, I got value of R is 30 ohm. So the first answer, the value of R should be 30 ohm to get maximum power at load 20 ohm. Now to find out maximum power at load, I need to calculate VTH. See here, this is the same circuit. I have already calculated that value of this R will be 30 ohm. So to calculate VTH, the load has been removed and voltage across these 2 points is VTH. So what will be this voltage? This voltage is equal to current through this 60 ohm resistance multiplied by this 60 ohm. What is the current? This current is because of this 180 volt and that will flow through this direction. So 180 volt divided by full resistive path is the current. 180 divided by 30 plus 60, that is the current flowing through 60 ohm resistance. That current multiplied by 60 ohm is potential across this 60 ohm. So ultimately VTH is 120 volt. Now putting those values in equivalent circuit, VTH is 120 volt, RTH is 20 ohm, RL is 20 ohm. Ultimately using this formula I got maximum power at load is 180 watt. Now checking whether my calculation is perfect or not. This is the equivalent circuit having same value as I have calculated, and this is the main circuit. Now power at load in main circuit and power at load in equivalent circuit, if these two are same with value 180 watt, then it will be confirmed that my calculations are perfect. Running the simulation. So in main circuit it is showing power at load is 180 watt. In equivalent circuit is showing power at load is 180 watt. So whichever the calculations I have done, all are perfect.